Hey guys, we're going to go over the Unit 1 test review. Okay, so let's dive right in. Problem number 1. Solve 4 times the absolute value of x plus 4 minus 2 is equal to 18. Okay, so when solving absolute value equations, the first thing we got to do is get the absolute value bars by themselves. So I start off by adding 2 to both sides. Okay, so this gives me 4 times the absolute value of x plus 4 is equal to, well, 18 plus 2 is 20. So I still have to get the absolute value bars by themselves, so I have to get rid of this 4. So I need to divide both sides by 4. So the 4's cancel. And that gives me the absolute value bars of x plus 4 is equal to 5. So now that I have the absolute value bars by themselves, I can set up my two equations. I can say x plus 4 is equal to 5. And I can say x plus 4 is equal to negative 5. And then I can solve. So to solve for x here, I would subtract 4 on both sides. So that gives me x equals 1. To solve here, I would subtract 4 on both sides. And that would give me x equals negative 9. Okay, so now what we have to do is plug in to check them. I have to check to make sure they both work. Okay, so I turn my calculator on. I say 4 math absolute value, press enter. And now instead of x, I'm going to plug in a 1. So I say 1 plus 4. I close it. And then I need to say minus 2. And if this works, I should get the other side of the equal sign, which is 18. Press enter. And I got 18, so it's good. So now we're going to check again, but this time instead of plugging in a 1, we're going to plug in a negative 9. Second insert. Negative sign. 9, press enter, and I get 18 again. So both of these are good. Neither one of them were extraneous. So my answers are x equals 1, x equals negative 9. Alright, let's go on number 2 here. Write the equation of the graph. Okay, so obviously this is absolute value because it looks like a V. So it's y equals, it's not reflecting. But however, I did go to the left 3 times and I did go down 2. So to go to the left, so I say absolute value. To go to the left, I say x plus 3. That means left. And then minus 2 to show going down 2. And there we go. Alright, let's go on number 3. Number 3 says, describe the graph of the second function, how the graph of the second function relates to the graph of the first function. Well, the first function is y equals absolute value of x. The second graph says y equals absolute value of x plus 7. This just simply means up 7. Number 4. What is the inverse for the function fx equal to 1/2 x plus 3? Well, hopefully remember what we talked about yesterday, that to find inverse, step 1 is to switch x and y. So we say x equals 1/2 y plus 3. So then to solve for y, now I need to solve for y, so I need to subtract 3 from both sides. So minus 3, minus 3, so I get x minus 3 is equal to 1/2 y. So what's the next thing I need to do to solve for y? Well, I need to get rid of this 1/2. Well, how do I get rid of a fraction? We'll start by just simply multiplying everything by its denominator. So everything is going to get multiplied by the denominator. So 2 times x is 2x minus 2 times 3, which is 6, is equal to, well, these 2's get to cancel, so you're left with 1y, which is just y. So y equals 2x minus 6. That's your inverse right there. Okay, let's try problem number 5. It says, what is the domain and range of the function? Write your answer in interval notation. Okay, our domain, remember, is all possible x values from left to right. Okay, and when we look here, we see that it's going to the left forever, and it's going to the right forever. So the domain is just going to be negative infinity to positive infinity. And then the range is always lowest y value to highest y value. So my lowest y value for this problem is arrows pointing down, which would be negative infinity. My highest y value for this problem is this point right here, which is a y value of 1. And then it gets a bracket because it's a closed circle. Okay, let's move on to problem number 6. Let f of x equal negative 6x plus 14 and g of x equals 16 minus 2x. What is f minus g? What is f plus g? So f minus g is negative 6x plus 14. That's what f is. So I can say negative 6x plus 14 minus g. So the g function is 16 minus 2x. Alright. So then this minus sign has to go to the entire g function. It says f minus all of g. So this minus sign has to go to both things in g. So that means it's going to turn a positive 16, so negative 6x plus 14. It's going to turn a positive 16 to being negative, so minus 16. And it's going to turn a negative 2x into being a positive 2x. And now I just start putting like terms together. Negative 6x plus 2x, that's negative 4x. 14 minus 16, that's negative 2. So bam, f minus g is negative 4x minus 2. Okay, so now we need to do f plus g. F, again, is negative 6x plus 14. Now I need to say plus g. Well, g is 16 minus 2x. So I say plus 16 minus 2x. So now, once again, I'm just going to put like terms together. Negative 6x, negative 2x makes negative 8x. 14 plus 16, that makes 30. So negative 8x plus 30. Okay? Alright, number 7. Number 7 says, what is the minimum value of f of x is equal to the absolute value of x on the interval from negative 3 to 6? Remember, the interval here, these are all x values. These are all x values. From negative 3 to 6, these are all x values. So in fact, you can make yourself an xy table, and you could say negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. So then, all you're really doing, guys, it says what is the minimum value. That means it's looking for the smallest y value after you plug all these x values in. So it says we're going to plug into the absolute value function. So you take your negative 3 and you plug it in. What is the absolute value of negative 3? 3. All right, now take the negative 2, plug it in. What is the absolute value of negative 2? 2. Take your negative 1, plug it in. What is the absolute value of negative 1? 1. So hopefully you've caught the pattern here, and I'm just going to keep going on. Okay? And then it says, what is the minimum? So look at your y values. What was the smallest y value you had? 0. So your minimum value is 0. Okay? Moving on. Problem number 8. The domain of a function is x such that x equals 7, and the range is y such that y is less than or equal to 6. What are the domain and range of the inverse? Well, guys, what does it mean to be an inverse? You mean switch x and y. Domain is really just x, and range is really just y. So to get the domain and range of the inverse, you're just going to switch these. So the domain of the inverse is bracket x such that x, now we're going to switch it, so instead of saying x equals 7, now I'm going to say x is less than or equal to 6. And close the bracket. And the range is going to be bracket y such that y is equal to 7. Close the bracket. And bam, there we are. That's it. You just had to switch them. Okay? Alright, let's move on. Problem 8. Just 8. Problem 9. Solve for the absolute value of 2x plus 4 is greater than 16. Guys, still the same first step. Do I have the absolute value solved by itself? Yes, I do. So I can start off saying 2x plus 4 is greater than 16. And then I can make a negative 1, and I have to remember to switch the sign. 2x plus 4 is less than negative 16. So now I just solve for x. So I subtract 4. So I get 2x is greater than 12. Divide by 2, so I get x is greater than 6. Same idea. Subtract 4. 2x is less than 20, negative 20. Divide both sides by 2, and I get x is less than negative 10. Okay. So now, all you got to do is check them. So give me a number that's greater than 6. That's right, like 7. 7 is greater than 6, right? So if you were to plug in 7, you get 2 times 7, which is 14. 14 plus 4, which is 18, is the absolute value of 18. What is the absolute value of 18? Just 18. So is 18 greater than 16? Yes, it is. So this is good. What about x is less than negative 10? Well, we could say negative 11. You plug it in. 2 times negative 11 would be negative 22. Negative 22 plus 4 would be negative 18. What is the absolute value of negative 18? Just 18. So is that greater than 16? Yes, it is. So both of these work. So I can say my answer is x is greater than 6 and x is less than negative 10. Okay. Oh, sorry, this is really an or. Sorry, or x is less than negative 10. And is when they're actually like pointing towards each other. I'll show you in number 11. Okay. Number 11. Solve. 3 times the absolute value of x is less than 15. Okay, the absolute value is not by itself right now, so I need to do that first. So I divide both sides by 3. So I say the absolute value of x plus 4 is less than 5. Now that I have the absolute value by itself, I can set up my two inequalities. I can say x plus 4 is less than 5, and I can say x plus 4 is greater than negative 5. So I subtract 4, so I get x is less than 1, subtract 4, so I say x is greater than negative 9. Okay, so you pick a number that's less than 1, such as 0. You plug it in. 0 plus 4 is 4. The absolute value of 4 is 4. 4 times 3 is 12. Is 12 less than 15? Yes, it is. So this works. What about x is greater than negative 9? Well, wait, didn't I just use 0? Isn't 0 greater than negative 9? Yes. And since I knew 0 worked, then I know that x being greater than negative 9 would work. Do you see how these two answers bounce in between each other? Because it's greater than negative 9, but less than 1. So if you wanted to, you could write it this way. I know I'd never really talk about it in class, but you could write it this way. So look at the signs. Is x still less than 1? Yes. Is x still greater than negative 9? Yes. So this is the exact same way of writing this, okay? We just say x is greater than negative 9 and x is less than 1. Okay? Moving on to number 14. What are the domain and range of the absolute value parent function? Now you need to remember that the absolute value parent function looks like this. Okay? And so the domain is just all real numbers, but it wants in set notation. So to write that in set notation, you'd write domain bracket x such that x equals all real numbers. Okay? The range, well, what's your lowest y value happening right now? Well, the lowest y value you see happening is 0. So we just say y is greater than or equal to 0. Alright? Let's try problem 15. Solve. So I need to get the absolute value by itself. So I add 3 first. So I get the absolute value of x plus 4 is equal to 18. So now that I have the absolute value by itself, I can set up my two equations. X plus 4 is equal to 18. X plus 4 is equal to negative 18. And then I can just solve for x. Subtract 4. So x is equal to 14. Subtract 4. So x is equal to negative 22. But now you've got to check it. So I pull out my calculator and I turn it on. And I go to math, num, absolute value, 14 plus 4. And if this works, I'm going to get 15. I got 15. Perfect. So now I check for the other one. Math, absolute value, negative 22 plus 4 minus 3. And it worked. I got 15 again. So these are both good answers. Okay, let's move on to problem 16. Oh, sorry. It's our last problem. Write the equation of the graph of f of x equal absolute value of x that has reflected across the x-axis, shifted left 5 and up 7. So it's just f of x is equal to a negative absolute value x plus 5 plus 7. And that's it. Okay guys, I hope this video was helpful. If it's not, please let me know. If you have any questions or I made any errors, please let me know. Alright guys, thanks for all that you do. Work hard. Let me know if you have any questions.